Makaku expressed, "We might need to revise all the course books on the start of the universe. It requires a long time to make a world like the Milky Way with 100 billion stars, which is a large number, billions of years old. Yet the James Webb Telescope has recognized 6 cosmic systems that exist a portion of a billion years after the Big Bang and are ultimately up to 10 times bigger than the Milky Way. Now there is no retreat. The James Webb Telescope has found quite possibly the oldest cosmic systems ever, and it's so tremendous and brilliant that it couldn't realistically be a galaxy from the early universe." Physicist Michio Kaku suspects we are now at the beginning of a new era and a new physics. This new physics could give more space for models like string theory and the multiverse and finally present us with the answer to the Hubble tension. Kaku chuckles at the latest discoveries of the JWST. Webb showed us galaxies that supposedly existed in the early universe, yet they are so enormous and so developed that they must have been formed before the Big Bang. There has already been evidence in science that the universe, as we envision it, doesn't completely match reality. You may have heard of the Hubble tension, a measurement inaccuracy in determining the pace of expansion of the universe. This issue has been known since the 1990s, and no one has had the option to solve the riddle. Now, Webb determinately shows us that there are different things amiss with our cosmology and astronomy. We may have been wrong on many levels. The Big Bang couldn't possibly have occurred 13.8 billion years ago if only 250 million years after it, there were already galaxies progressing in the universe which, as Kaku points out, are bigger than our Milky Way. According to our current understanding, galaxy formation is a complex process that requires billions of years to produce galaxies like our Milky Way. Webb found many of these old, perfectly formed, and enormous cosmic systems. Every one represents a riddle to researchers. But not just that, Webb also showed us pictures of extremely large black holes that contained more than a billion solar masses only 500 million years after the supposed Big Bang. These discoveries show us that our scientific understanding was wrong, and the launch of the James Webb Space Telescope set off one of the greatest crises in modern cosmology. Michio Kaku chuckles when he points out that some of the newly discovered galaxies appear to be up to 10 times larger than the Milky Way. The famous astrophysicist from the USA is one of the experts who have pointed out that our science has significant gaps. His theories, which conceived a unification of quantum field theories with the astronomy of enormous phenomena such as stars and galaxies, were not treated seriously in conservative scientific circles. It's precisely these conservative camps that now have a colossal problem because their rigid views on the universe and their ideas about the evolution of matter and the Big Bang are reeling. Rather, we will get a new physics, and because of Webb, we may find totally new parts of our universe. They really can't say that they didn't know anything because, in addition to the Hubble telescope, there were already various other signs before Webb that the old thought of the Big Bang expansion can't be completely right. Even the old Hubble Space Telescope found some dubious spots of light in the supposedly early universe. One of these discoveries was the galaxy known as GZ9P3. Hubble just recognized the galaxy as an extremely obscure spot of light, which was undoubtedly there but didn't allow any more precise studies. Only Webb shed light on the darkness and took another look at GZ9P3. It worked out that this light was truly emitted by an extremely old galaxy. Under Webb's sharp eyes, the galaxy showed a redshift of Z equal to 9.3, which amounts to nothing less than that we are looking at a galaxy that existed only 510 million years after the Big Bang. This means that GZ9P3 is also a primordial galaxy that is far more massive and mature than would be expected for its age. The galaxy, moreover, shows several irregularities that give experts something worth pondering. It has an unusual shape with 2 bright spots revealing its 2 dense cores. This suggests that we are actually looking at 2 galaxies and that we are seeing a galaxy merger in the evidently early universe. Mergers of 2 primordial galaxies in the early universe wouldn't be surprising, but even if we consider these 2 galaxies separately, they are too large and too developed to be truly child galaxies in a young universe by our old standards. It requires billions of years for galaxies to reach this level of development. But we see the galaxy as it was 510 million years after the Big Bang. The galaxy is dominated by young, bright stars, and scientists have found specific elements like silicon, carbon, and iron that show older stars. These elements are not typical of the first stars. They only formed after many stages of stellar evolution. This fact, moreover, opposes us seeing a young universe here. As you can see, something can't be here, and researchers have not yet found the solution to the problem. The discovery of additional old stars suggests that stars formed earlier and enriched the universe with metals faster. The old stars in GZ9P3 may also show that the universe developed chemically faster than thought, or we may have been wrong about the age of the universe. And this is where the Hubble tension comes back into play. Is expansion a lie? Did you know that the expansion of the universe has never been fully proven, and that the idea that the universe is expanding is a theory for which there was significant evidence? Yet problems with this theory soon arose. Expansion is one of the foundations of our modern cosmology. In the 1920s, it seemed like a revolution, just as Webb is changing our view of reality. Let us consider for a moment how this realization happened, what evidence supports it, and what inconsistencies or irregularities there are. The first sign of the expansion of the universe came from Vesto Melvin Slipher, an American astronomer who studied the spectral lines of galaxies during the 1910s and found that many of them displayed a redshift, indicating that these galaxies were moving away from us. However, the decisive breakthrough came in 1929 when Edwin Hubble, also an American cosmologist, found the relationship between the distance of galaxies and their recessional velocity. Edwin Hubble used the Doppler effect to measure the velocities of galaxies and found that more distant galaxies were receding from us faster. This led to the formulation of Hubble's law, which states that the speed at which a galaxy recedes from us is proportional to its distance. For a long time, this law was considered the main evidence that the universe is expanding. In addition to the redshifts, there is further evidence for the expansion of the universe. The cosmic microwave background, CMB, the background radiation of the universe dating back to when the universe was around 380,000 years old, was discovered in 1965 by Arno Penzias and Robert Wilson. The uniform temperature distribution of this radiation in all directions indicates that the universe was once much denser and hotter and has been expanding since. Further evidence was the so-called Big Bang nucleosynthesis, which states that the abundance of light elements such as hydrogen and helium formed in the early universe is consistent with predictions of an expanding universe. Despite this evidence, there are also scientific inconsistencies and unresolved questions about the idea of expansion. The most interesting of these is the Hubble tension. Hubble tension refers to a discrepancy between the values of the rate of expansion of the universe when different methods are applied. One method for determining the Hubble constant uses satellite observations of the CMB. The measurements were carried out with the Wilkinson Microwave Anisotropy Probe and the Planck Space Telescope, among others. These measurements generally result in a Hubble constant of around 67 to 68 kilometers per second per megaparsec. Another method uses so-called standard candles, whose light provides fixed points for measuring distances and velocities in the universe. Researchers use Cepheid variables and type Ia supernovae in particular as such standard candles. Cepheids are pulsating stars whose luminosity is related to their pulsation period. Type Ia supernovae have a normalized brightness. By measuring their apparent brightness, distances can be determined and combined with redshifts to calculate the expansion rate. This method yields a higher Hubble constant of around 73 to 74 kilometers per second per megaparsec. Several explanations for this discrepancy have been proposed in the past. There could be a systematic error in the measurement methods or assumptions, and thus the results are distorted. Many experts suspect a misunderstanding in the theories of dark matter and dark energy, both of which are said to make up the majority of the universe, but we have not yet been able to measure or prove them, so we know very little about their actual properties. Previously unknown properties of dark matter and dark energy could explain the tensions. According to James Webb's current observations, researchers even suspect that dark matter and energy could change their properties, making them genuinely immense or undeterminable. If this is true, we are unlikely to ever fully describe the universe scientifically. However, there are other explanations for the Hubble tension. The standard candles could be affected by their specific surroundings and thus not be reliable measurements. Right now, it looks as if we are heading towards a new physics that will bring new insights and models. The expansion, or rather the drifting apart of certain areas of the universe, is certainly not a lie but a clearly observed reality. However, it's now unclear whether the entire universe is truly expanding and whether it is drifting apart uniformly. Observations of areas with lower expansion and of phases with an increase in the rate of expansion rather suggest that we are in a generally dynamic structure. However, this doesn't necessarily have to have had a single starting point. Has Michio Kaku been right all along? New observations by James Webb show that physicists like Kaku could be right. The observable universe could simply be a bubble in a larger multiverse that is much older than we previously assumed. This would explain why astronomers find galaxies that appear much older and more mature than they should be according to the Big Bang theory. Other theories propose that the universe expands in a phase process. There may have been multiple bangs and expansion phases. These theories suggest that the universe periodically expands and contracts, which could explain why we observe old, mature galaxies in a supposedly young universe. Physicist Michio Kaku expresses optimism that the new observations will lead to a breakthrough in physics. He emphasizes that the Hubble tension is a sign that something is wrong with our current models and that the new findings will significantly advance our understanding of the universe. Kaku's theory of the multiverse and the idea that our universe is just one of many in a larger multiverse could now be supported by Webb's findings. These observations could help explain why we see mature galaxies in the early universe and solve the puzzle of the Hubble tension. Kaku and other physicists hope that the new observations will lead to a revision of our theories about the universe and the development of new models that better match the observed reality. This could be the beginning of a new era in cosmology and physics, where we gain a deeper understanding of the universe and its origins. The discoveries made by the James Webb Space Telescope and their implications for our understanding of the universe are just beginning to unfold. The coming years will likely bring more groundbreaking findings and advances in our knowledge of the cosmos. Until then, the scientific community will continue to debate and refine their theories, striving to unravel the mysteries of the universe.